Good day everyone. Welcome to our new tutorial. Today we're going to tackle about infinite geometric series. Infinite geometric series is the sum of an infinite geometric sequence. So in order for us to know on how to do it, we need first to familiarize ourselves with the following condition. The first condition is we can use this formula if the common ratio is between -1 and 1. So if you're going to write a number line, this will be -1, this will be 0, and this will be 1. The value of your common ratio should be between this and not exactly -1 and not 1. So for us to use this formula. Now, if the value of r is less than -1 or greater than 1, then the geometric series doesn't have a sum, meaning we cannot compute for its sum. Now let's put that in an example. Find the sum of an infinite geometric sequence 9, 3, 1, and so forth. If we compute first the common ratio, we can see that the common ratio is 1/3. So since 1/3 is between -1 and 1, then we could use this formula. Now to solve this formula, let's just substitute the given that we have. Substitute 9 for a sub 1 because that is our first term, and 1/3 for our r because that's our common ratio. So we need to simplify it by subtracting 1/3 from 1. Then we have 9 over 2/3. Now now and to solve this, we need to consider that 9 as a whole number over 2 over 3. Since 9 is a whole number, so there's a 1 for its denominator. Then let's get the reciprocal of 2 over 3 and multiply it to 9. That would be 3 over 2. Now all you have to do is to multiply the numerator and denominator to the denominator. 9 times 3 is 27 and 1 times 2 is 2. So therefore we have the sum of the infinite geometric sequence 931 is equal to 27 over 2. In this example, find the sum of the infinite geometric sequence 2, -8, 32, and so forth. This is an alternating signs geometric sequence. Therefore, we can say that the common ratio is negative. Now let's try to divide 8 to 2 and 32 to -8. Then we can get a common ratio of -4. Since -4 is less than -1, then therefore this sequence doesn't have a sum or it has no sum. So that's how easy it is. Now let's proceed to our examples. Example number 1. Find the sum of 4 plus 2.4 plus 1.44 plus 0.864 plus infinity. So we can solve first for the common ratio, and that is 0.6, and our a sub 1 is 4. Then all we have to do is use this formula and substitute the value. Then 1 minus 0.6 is 0.4. And if you divide 4 by 0.4, then you get the sum of 10. If we're going to add this to infinity, we have the sum of 10. Number 2, evaluate 8 plus 6 plus 9 over 2 plus 27 over 8. So again, first, let's find the common ratio. 6 divided by 8 is as it is, 6 over 8. Then let's simplify that, and we have 3 over 4. Now, since 3 over 4 is between -1 and 1, then we could use this formula. Again, let's substitute the value. 8 for 1, and 8 for a sub 1, and 3/4 to r. Then 1 minus 3/4 is 1/4. So again, to answer this, we just use 8 over 1, then multiply to 4 over 1. So that would give us a sum of 30. Now for example number 3, -1 over 27 plus 1 over 9 minus 1/3 plus 1 minus 3 and so forth. As you can see that the sequence is increasing in value of the coefficient disregarding the sign, and it is an alternating sign. So therefore, we could solve for the common ratio as negative numbers. So 1 over 9 divided by 1 over 27 is negative 3. And negative 3 is less than 1. So therefore, this series doesn't have a sum. Example number 4. Express 0.42, 42, 42, and so on as a ratio of two integers in lowest term. Now we can rewrite 0.4242 and so on as this, and it forms a geometric series. Now if we could get the common ratio of this series, we can say that the common ratio is 0.01. Now if we have the valuing given, we could just use the infinite geometric series formula to solve for the value for the ratio of 2 in changing this decimal number into a ratio of two number in lowest term. Now we have 42 over 99. Now let's simplify it and we have 14 over 30. Thank you everyone for watching this video tutorial. Hope you learned something today and see you on next video. Bye bye.